stoichiometry of a chemical reaction. You've done stoichiometry of a recipe. This is very similar. Everything's going to look the same. You have a reaction. If we go to space, we have to have some way of generating oxygen. We take some water with us. This is a water molecule. This is a hydrogen molecule and an oxygen molecule. Hydrogen and oxygen do not exist as single atoms like many other elements. They exist as molecules. So this is not the correctly balanced reaction. You actually need two of these to get those two oxygen atoms that you need for an oxygen molecule. But that gives you 4 hydrogen atoms. So you need 2 hydrogen molecules, and that's a 1, of course. So now you have a balanced reaction. And you have a ratio of 2 things of water will give you 2 things of hydrogen and 1 thing of oxygen. Of course, this could be 2 molecules. This could be 2 molecules and 1 molecule. But in chemistry, we deal with trillions and trillions and gazillions of atoms. So this is 2 moles, 2 moles, 1 mole. Everything is the same. Question. How many grams of O2 are produced from 4,000 grams of H2O? It's going to be 4 steps. 4,000 grams of H2O. And then the next step is to add up and find the molar mass of H2O. It's always going to be 1 mole up there. The molar mass of H2O, discarding the 2. Do not use the 2. There are 2 hydrogens times 1. There's 1 oxygen times 16. And that's 18. And then we are discussing these 2 substances in the problem. So 2 moles of H2O. You do use this 2 for this 3rd step, just like you do in the stoichiometry of recipes. And that's 1 mole of O2. And then 1 mole of O2 is 32 grams of O2. This is not a 1 because that's a 1. This is always a 1. This is going to be whatever the reaction gives you. Plug it into your calculator. Get the answer. Multiply across the top, multiply across the bottom, divide top by bottom. Also in space, sometimes they take solid pieces of this thing called lithium perchlorate. And so that will generate oxygen, lithium perchlorate. Now, if you were in Miss Godwin's room, she would just give you the name, and you would have to derive the formula. And then you would have to know that it decomposes to this. So you would have to be able to do all of this on your own. And so we're going to balance this by putting a 2 here. You would have to balance that on your own. And so the question is, how many grams of oxygen are produced from 5,000 grams of lithium chlorate? Again, it's 4 steps. Same 4 steps. 5,000 grams of lithium perchlorate over 1, not over 1 anything. We're just reminding ourselves that this measurement or this amount is in the numerator because that helps us set the problem up correctly. And so then we're going to have to find the molar mass of lithium perchlorate. We're just going to look at lithium perchlorate. We're not going to use this 2. We're just looking at lithium perchlorate. So we've got 1 lithium times 7, 1 Cl times 55, and then we've got 4 oxygens times 16, that's 64, 55 and 7, that's 62, and so that's 126 grams. So 1 mole is 126 grams. A gazillion particles weighs 126 grams. And then for every, of according to the reaction, for every 2 gazillion particles we have of lithium perchlorate, we're going to get 4 gazillion particles of oxygen, and then that is 32 grams of oxygen because it's 2 times 16. Multiply across the top, multiply across the bottom, divide top by bottom, you get an answer. That is the limit of the stoichiometry of chemical reactions you have to know.